We live in a world of 4 dimensions, 3 spatial dimensions, up, down, left, right, forward, backward, and the 4th dimension, time. But what if there are more? The concept of a 5th dimension has captivated scientists and science fiction writers alike, hinting at hidden layers of reality beyond our direct perception. The scientific journey into extra dimensions began surprisingly early, even before Einstein finalized his theory of general relativity. In 1919, Theodore Kaluza proposed a radical idea. What if our universe has a 5th spatial dimension, curled up so tightly that we can't see it? He showed that if you extended Einstein's equations to include this extra dimension, the mathematics naturally yielded not just gravity, but also Maxwell's equations for electromagnetism. This was a profound unification, 2 fundamental forces emerging from the geometry of a higher dimensional space. Later, Klein refined this, suggesting this extra dimension was compactified, meaning it wraps back on itself in a tiny, unobservable circle. Imagine an ant walking on a garden hose. From afar, it looks like it's moving in one dimension along the hose. But up close, the ant can also move around the circumference of the hose. That's the hidden, curled-up dimension. For us, this extra dimension would be incredibly small, perhaps a trillionth the size of an atom, making it imperceptible to our senses and even our most powerful microscopes. Fast forward to today, and the idea of extra dimensions is central to some of the most ambitious theories in physics, particularly string theory and M-theory. These theories attempt to unify all fundamental forces and particles by proposing that the universe's most basic constituents aren't point-like particles, but tiny, vibrating strings. For these strings to vibrate in all the ways necessary to produce the particles and forces we observe, the theories require far more than 4 dimensions, typically 10 or 11 spacetime dimensions. In these frameworks, the extra spatial dimensions, often 6 or 7 of them, are also compactified, but in much more complex shapes known as Calabi-Yau manifolds. The specific way these dimensions are curled up dictates the laws of physics we experience in our familiar 4 dimensions. Different compactification patterns could, in theory, lead to different universes with different physical laws. Another intriguing concept emerging from higher dimensional theories is the brain world scenario.